Good. My name is PJ Walker. I am the GPS geek. I've literally integrated GPS into hundreds of thousands of devices around the world for many applications, from agriculture through to robotics, IOT, aerospace. And what I really want to talk about is the advent of more precision into GPS and why we should use more precision and the benefits for these services that we are providing. So the key for me here is, well, we'll go through, is the why we're going to do it, and then I'll explain how we do it. But I guess the key is understanding, and I apologize if people understand this already, but if we look at GPS as a whole, if you look at your phone, you're getting about a 3-meter accuracy. So if you're the dot in the middle, where your phone is reporting your position, or normal devices like your car, satellite navigation, or anything else, could be anywhere within that 6-meter circle. And when we come down to talking about precision, we're talking about dropping it down to under a meter at first, and then if we need to, we can drop GPS precision all the way down to 2.5 centimeters. And it obviously depends on your application, what the cost requirement is, and why you might want to do that. So there are lots of potential reasons why you want to do this. You know, if you look at agriculture, it's because we want to reduce the amount of fuel we're using or the amount of inputs we're doing and all of that kind of thing. But when we start looking at IoT, it's generally about efficiency and just reducing cost. And then there are lots of things we can add onto the end of it. I'm not going to go into all of this, but there's lots and lots of reasons we would do it. Location awareness is a great one. Lots of applications within health and safety and that kind of thing. Smart transportation. Wearables is going to be a very, very big thing to have high precision GPS on, even if it's just for sports and fitness, tracking efficiencies, tracking sports development and that kind of thing. And then when we look at all of these things, what does that enable us to do? Mostly it enables us to bring in better business models, more revenue opportunities, and a more dynamic solution for the customer. So whether that's a pricing model, whether that's a more efficient model for their use, and whether that's based on very, very specific locational settings that we can create within the business model for them. So to give you some examples of why that's really important, and one that's probably really easy for everyone to understand, is last mile delivery and gig economy. I mean, we'll have all have known of all of these companies that are up here, and I think it's, you know, this is an area where a lot of precision is already being implemented, probably at the sub-meter level as opposed to really, really high accuracies, though DHL and Uber are now implementing sub-10 centimeter accuracies for many of their applications. And that's because, as you can see here, 5% of all of the last mile or gig economy deliveries that made fail. And fail's a very strong word, but what failure means is someone misses a turning or misses the address, has to go up to the end of the road, turn around and come back. And that just takes time. And it doesn't seem like a lot, it doesn't seem significant. But if you look, in 2023, Uber were carrying out 17.4 million journeys a day. So if 5% of those are 5 minutes longer than they need to be, that's years of lost time and expense, all because they needed just slightly more accurate information. So if we can increase the accuracy of the information that a driver's getting, that the system behind the driver is providing, and we can reduce that from, because you can't get rid of them all, but we can reduce it from 5% to 2.5%, we're talking about saving millions and millions of dollars a year. And what we're then doing is we're moving away from an address-based solution. We're all very used to putting an address into a satellite navigation system, which is great for us as personal users when we're going from point A to point B. But if you have a positional solution for a delivery driver or for someone who's doing Deliveroo or Uber or whatever it might be, then that makes their job much, much easier and much, much more efficient. So that's just one example where precision can really, really improve on how we're carrying out our day-to-day tasks that are already taking place. We can just make them better. In addition to that, we then have health and safety in construction and all sorts of environments. This product here is a wearable device. I've got some of these here if anyone wants to see them later. But this is worn on the arm, and it was predominantly developed for people who work on the railways, because shutting down a railway is a very, very expensive act. And so what we're able to do with this device, and these are accurate to around 5 centimeters, is we're able to geo-fence the railways. So you can see here we've got the red zone. That's where trains are actively going to be running. And this green zone here is where people will be able to work, where we know the trains have been shut down and won't be active. The most dangerous thing in this situation is situational awareness. If there hasn't been a train in the red zone for a few minutes, 10 minutes, 15 minutes, it's very easy for someone to cross from the green zone to the red zone and put themselves in danger. What this system does is when it notices that the worker has gone from the green zone to the red zone, it gives them a loud, audible alert which won't stop until they re-enter the green zone. It also notifies the site manager, and it can also keep a record of that so that we have the near-miss incident reporting and everything that a contractor on the railway, such as Siemens, would need, so that they can show that they are behaving in a responsible way. We also add the equipment now to the machinery that's either working on the railways or on construction sites. So these devices are now networked together. They now know the position of the heavy machinery and the workers, and so we have a safe zone around the machinery. So if a worker comes within that safe zone, it will effectively stop the machinery dead in its place. Up until now, there are thousands of people across Europe whose job it is just to stand by those machineries those bits of machinery while they're working, in order to make sure that everyone who's in that area is safe. They can tell the driver to stop, they can tell people to get out of the way. But with this technology, we don't need to have those people, and they can be off doing something far more productive. And all of this is done with high accuracy, reliably at about a 5 centimeter level. So once they've crossed that green line into that red line, after they've moved more than 5 centimeters into it, their alarm's going to go off and people are going to get notified. So the question is, why is this now, and why hasn't it always been done? And that's because we have the issues of standard GPS. Standard GPS is accurate to around that 3 meter point, purely because a standard GPS satellite, as I'm sure you're all aware, they're going around the Earth like this. They are 20,000 kilometers in space, and we're measuring time. So we're measuring the speed of light from those to figure out your location, and the speed of that changes as it enters the Earth's atmosphere, and that makes it incorrect. It puts it off by, as I say, about that 3 meters. A really good way of thinking about it is how light refracts as you shine it through glass. It changes direction, and the same thing is happening here. Now we have more satellites in the sky than we've ever had, so it's pretty much the best it can be, and on its own, without any sort of assistance, we're probably at the limit of physics with it right now. It's as good as it's going to get, unless we add in some form of augmentation. And in order to get these accuracies down to a sub-meter and then down to that 2.5 centimeter level, we use reference stations. So what these they are what we call reference or base stations. They're located all over the world, and they are recording their exact position. So their exact position is known. The device is contacting the reference station with its GPS position, and the reference station is telling it how far off its GPS position is, and that makes it super accurate, because we're just giving it a correction, and we're correcting that information. And we've got a cute little robot here, but it can be any GPS device that is enabled and has the capability to read all of the right GPS signals. These devices now, we're just getting to a point where for years and years and years to have a device that was capable of this kind of algorithmic calculation, they were thousands and thousands of dollars. We're now at a point where the manufacturers are building these from anywhere from $60 to $150 to maybe $600, depending if you really need a very specialized application that needs lots of anti-jamming, anti-spoofing, that kind of thing. To give you an example of the network range of these devices, this is the current product that is available. So you can see these here this is a representation of all the available reference stations currently on the globe. They're operated by different people, some are operated by governments, some of them private organizations, and you can see there are large areas where there's nothing, or we don't have access to them. They might be there. And in those areas there are other solutions, but the maximum accuracy we'll get without a proper ground-based station or reference station within a certain distance is probably about 20 centimeters. There's other things we can do algorithmically and that kind of thing, but 20 centimeters is probably the best we're ever going to do, and indeed, in a lot of these areas, that's as accurate as we get even for airliners, fighter jets, that kind of thing. Though there are other applications we can add into that we can augment that system with. So the technical, so we have the inaccuracies of the standard GPS, we have the technical solution to correct that, and then we can, on top of that, we can augment it. So if you have ever seen the Waymo taxis or Tesla self-driving mode, they're using visual aids, so camera systems or LiDAR systems to, again, augment on top of this so that we can get almost what we would refer to as dead reckoning or perfection in that situation, so that we can navigate around all kinds of different situations. So why are we all going to do it? We've got accuracy, so we get to turn around to our customer and say, we're more accurate, we're better than everything else out there. It's far, far more efficient. If we know where something is to a very, very fine detail, it's always going to be a much more efficient solution, and then it gives us enhanced capabilities. Once we can position something, for instance in robotics, very, very well, we're able to navigate much better, we're able to avoid obstacles much better, and it speeds everything up for us in orders of magnitude. So there are implications. If you have a standard GNSS chip, like that's in a lot of mobile phones until recently, most mobile phones, brand new ones now, would be capable of some level of precision, and adding these augmentation systems in. But if you have a system that has got a very, very standard GNSS chip in it, there's not a lot that can be done in real time, though we can post-process information if you collect data from those and make it more accurate. In real time, it's very difficult to do anything with those. So we need the newer technology for these newer devices. But with that, once we have them, everything else that we need to integrate the solutions into existing software platforms and that kind of thing is all there. The APIs, the SDKs, they're all existing. We can create solutions to make these devices compatible, these GNSS modules compatible with existing hardware. Data management and storage, it's a lot about what everybody is here for today, and this has become a very, very simple solution, and we have some great communication and network solutions now. So even if we have situations where we are deprived of a mobile phone signal or anything like that, we've still got, because we're using satellites anyway, we've got L-band communication, so we effectively have got constant communication regardless of the ground resource that we have. And then we have to make sure that we perfect everything we do, because they are sensors at the end of the day, with a lot of testing and calibration. Ultimately, what does this mean for service providers? So we've got enhanced location-based services, whether it's robotics, we're just tracking a device, whether we're navigating something, whether we're trying to improve a delivery service, everything is enhanced with precision. Obviously, that relates to operational efficiency gains. We've got an improved customer experience. One would hope that the extra cost and the extra skill required would give you a competitive advantage. And then on top of that, we have the extra monetization. So whether it's monetization to our direct customers, or the fact that we're able to monetize what happens at certain times of day, for instance with electric vehicle charging points. If we have the data coming back to us, we anonymize that, so we're not breaking any rules about personal data collection or anything else, but we can look at how busy a certain area gets, at certain times of day. We can use it for traffic predicting, traffic reporting, weather predicting, weather reporting, to a much, much higher level and a much, much more advanced level. And where does this move to? So us being able to be accurate right now is reliant on these ground reference stations. And what we are constantly working on is how we make this easier and we remove the requirement for a lot of resource. So there are advancements in satellite technology. The European Space Agency with its Galileo project has now got HAS, which is a satellite augmentation, so that's removing the reference stations. Right now it's testing to about 20 to 50 centimeters accuracy, but it will improve in the future. The end product itself, the hardware in the device, with the integration of AI and machine learning, will get better at correcting its own position, especially now we have all of these reference stations and we're collecting all the data and we're able to mine that to understand the effect that has on the standalone GPS positioning. And with the, obviously with emergence of 5G and edge computing, we've just improved dramatically on our communication with these devices. One of the things that has really helped us just in the last 5 years is the increase in the number of satellites. So we had the GPS, which is the American system. We had GLONASS, which is the Russian equivalent, which is very out of date and not used as much anymore. But with the addition of Galileo and with the addition of the Chinese system Beidou, we've got much greater coverage, and there is very rarely a situation where a device cannot see GPS or GNSS solutions. And the growing adoption in new sectors. As we talk about last mile delivery, or we talk about the health and safety devices, robotics, all of these things are now able to very simply integrate and adopt this technology, and it gives us a great opportunity to bring it into as many things as we possibly can for a very, very affordable price. Which largely brings me to the end of what I've got to say on this. You could get very, very technical with it all, and I didn't want to do that today, but all you need to understand is that GPS is there and it's very easy to use. If we want to use it to a very accurate, very precise level, we have to augment it with something, whether that be reference stations, whether that be vision technology and that kind of thing, and that makes life much, much more efficient. And it makes the end product a much, much better product for the consumer at the end of the day. I've got my QR code here if anybody would like to ask any questions, whether it be about how we integrate these things into devices, how we get the data from those devices into your platforms, then feel free to ask those questions and I'll see what I can do for you.
Well, thank you so much. So now it's time for questions. If you have, you can write it down on the QR code. So the first question we got is, how can Odoo's IoT and precision GPS integration be leveraged to optimize field operations such as route planning and asset tracking while maintaining data accuracy and low latency?
Yeah, so latency, sorry, can I read the question? I couldn't.
Yeah, sure. It's the first one.
Okay, so when we're adding augmentation, or when we're adding precision to the GNSS solution, that's being done on the device. So when we're doing that for route planning or asset tracking, the information that we then get back from the device, which is probably filling a database for us for our asset tracking or anything like that, isn't being slowed down at all. So we're feeding information in to improve the accuracy. The accuracy is being improved within the device, within the module itself, and so our output from that device is exactly the same as it was before we added in precision. So it shouldn't slow your data down or anything like that. It should just enhance what you're offering currently.
Perfect. Next one, which is the following. Due to these devices' high accuracy, are they still effective in marine applications, particularly in high seas?
Yeah, so we have, we do a lot in marine for shipping and oil and everything like that, where we have a dynamic positioning solution. So boats have to stay in exactly the same position all of the time. They've got motors running all around them to always keep them in position. And we generally, you're talking about a 15 to 20 centimeter accuracy. But yeah, we can, with calibration and testing, we can keep that. We can keep that even in very, very difficult sea conditions. So we do it with, oil rigs, shipping, all sorts of kind of stuff. Yeah.
Perfect. Someone is interested in contact with you, so I don't know if you have a mail or somebody is interested, they can contact you after we finish.
Yes, yeah, sure. I've got some cards and stuff here, so just come and say hi.
Perfect. The following one will be this one. Considering the railroad fencing situation, is the system also used, for example, in the prison system, detaining people within a certain perimeter? If so, are there any worries about misses in the future? For instance, Hollywood-like situations with exploding bracelets, electroshock bracelets.
Yeah, so I mean, we have, everyone already has tagging systems for low-risk prisoners, so that's so that we can track them or we can give them a curfew. They are not terribly accurate devices; they're in the 3-meter range. But the idea is that the police will know if they're out after 10 o'clock at night, or if they've gone out of a certain area, and they can locate them. Whether the dystopian future of remotely harming people if they do the wrong thing is a thing I'm not the person to ask, unfortunately. I'll stay out of that one, I think.
Maybe that would be for a lawyer.
Yeah.
The question. And the last one that we got is, can I use it somehow in-house or in a tunnel exit? There are solutions which are already connected to Odoo?
There are solutions that are connected. They're already unique solutions or tailored solutions for particular customers that are connected to Odoo through database systems. Yes, you can use it in tunnel systems. So in the railway system, we use it in tunnels, but we have to use a system called Dead Reckoning, where we add accelerometers into the process. So if we know we're going to have to go through a tunnel or a GPS-deprived environment, we add another sensor in, which allows us to measure from one location to the next location until we regather that position.
Okay, so there's no more question. We got some minutes left. If someone wants to ask something. No? So
all good?
I think it's done.
Brilliant. Thank you very much.
Thank you so much.
Cheers.